Hello everyone, welcome to the 11.4 video where we're going to talk about area of regular polygons and area of composite figures. So our objectives will be to find those two things. Alright, first we're going to start with regular polygons. A couple of things we need to know about regular polygons here. The central angle of a regular polygon is equal to 360 divided by n, where n is the number of sides of the polygon. So when we're talking central angle of polygons, central angle here, an example of one would be angle APB. Okay, so the measure of angle in this case APB is equal to 360 divided by the number of sides. This is a 1, 2, 3, 4, 5, 5-sided figure, pentagon. So the measure of the central angles of this pentagon, all central angles, there's more than one here, would be 72 degrees. All right, so that's central angles of regular polygons. Again, 360 divided by number of sides. Also of interest to us, and we won't use the central angles too terribly. Well, we will use them quite a bit. But also of interest is the idea of what an apothem is. An apothem, again, is a measure from the center of the polygon perpendicular to one side of that polygon. So here, PF is an apothem length, right? And then lastly, radius, kind of same idea here. Radius goes as a circle from center to vertex, all right? And so that'd be a radius of the central polygon. Excuse me, a radius of the regular polygon. So the formula for area of a regular polygon, we're going to focus on this one. Area equals 1/2 A is the length of the apothem. You can see that in the diagram over here. A is the length of the apothem. And P is the perimeter of the regular polygon. So area equals 1/2 apothem length. Again, that's the measure from center perpendicular to one of the sides, and then times P, which is perimeter. So that's the area of a regular polygon, and that's the one we'll use and we'll see on our quizzes and our test. So these problems can be pretty complex. Break it down into smaller parts though here. So let's find the area of each regular polygon, round to the nearest tenth. So here we've got a regular hexagon. Hexagons are 6-sided. So let's keep that in mind. So area is 1/2 apothem length times perimeter. So it'd be probably useful to find perimeter. Of course, to find perimeter, that is just all of the side lengths added together. Here there are 6 congruent sides. So 6 times, looks like they're all 3 meters long. So 6 times 3 meters. The perimeter of this hexagon would be 18 meters. Now to find the apothem length, we need to focus in, I'm going to kind of highlight with blue, on this triangle here. And even more so on one of those right triangles in just a minute. But thinking of this triangle, angle ABC is a central angle. Angle ABC is a central angle. So we can find the measure of that, 360 divided by the number of sides, 6. So the measure of angle ABC would be 60 degrees. That is useful because now when I take a look, and I'm going to use green this time, at this right triangle, blow it up here. So I take a look at this right triangle. It's not really drawn to scale here. I would have a side length that is 1.5 meters. That's this side length right there. And then I've got a half of the central angle. Well, the central angle was 60 degrees. So half of that central angle would be 30 degrees. And that's this angle DBC that we would be looking at. So using this, why am I concerned about this right triangle? The length here is the apothem. That A would be the apothem length of this regular polygon. So finding A would I have perimeter. Finding A will allow me to find the area. So let's use our 30-degree angle. A is the side that's adjacent to that. The side that we have, 1.5, that is opposite it, so I should use tangent. So tangent of my angle is equal to opposite 1.5 over adjacent, which is A. My pen decided to stop working here. Let's see, can't troubleshoot it a little bit here. And nothing is wanting to work. What has happened? Oh, yikes. Ah, there we go. It's caught up. There's just a little tech issue there. Sorry. All right, so that is A. Let's multiply both sides by A. So now I have A times tangent of 30 equals 1.5. Divide both sides by tangent of 30. And here we'll need our scientific calculators, of course. Likely you might not have one there at home, so this would just be 1.5 divided by tangent 30. You should get that A is 2 point, let's say nearest tenth, so let's round this to the nearest tenth, 2.59, so 2.6 meters. So I can use apothem and perimeter to find my area now. Plug in here. So area is 1/2 apothem, 2.6 times perimeter we said was 18. And that gives us 2.6 times 18, 23.4. So the area of this regular hexagon is 23.4 meters squared. All right. So that's a regular hexagon. This next example we're going to look at is a regular pentagon. I'm going to use the same principles here. All right. We see our triangle kind of set up similar. Instead of a side length, though, we are given the radius. The radius is 10 inches. So it does change the problem a little bit. We can't so easily find perimeter, and we can find the apothem pretty easily, but the perimeter is also going to take some work here. But the main focus of the problem is, again, going to be on this triangle that we see here. And more specifically on this right triangle created. So again, going to end up using some trig here. And if we remember, to do that trig, we needed the measure of the central angle. So let's find the measure of angle, what that'd be, RPQ. That would be the measure of the central angle, the whole angle there. The measure of the central angle, again, 360 divided by number of sides. This is a pentagon, so 5 sides. So that would be 72 degrees. All right, now when we specifically focus in on my green triangle, right, we have half of the central angle. We have half of the central angle. So half of 72 would give us a 36-degree angle. Okay, and we've got the radius is 10 inches, which ends up being the hypotenuse of this right triangle. So I need a couple of things. We can find apothem length, so let's label that A. That would be our apothem length here. That would be adjacent. Apothem's adjacent, and we've got hypotenuse, so adjacent and hypotenuse. Recall we use cosine. Cosine of 36 equals adjacent, our apothem, over the hypotenuse 10. So multiply both sides by 10 here. We get 10 times cos of 30, cosine 36, excuse me. 8.09, again we'll use the nearest tenth, so we'll call the apothem 8.1 inches. So that's apothem length. All well and good. what do we need? For area, we need 1/2 apothem. We've got that. And perimeter. Can't so easily find perimeter. We don't know what these side lengths are. Okay, we know they're all congruent because it's a regular polygon, but we don't know what those lengths are. Okay, we do know, we'll call it x here. X is half of one of those sides. So if we could find x, use some trig to find x, we could use the Pythagorean theorem at this point to find x. But we need to find x and then double it, and that'll give us our side length. Therefore, we could find perimeter. So let's work on finding x. I'll just use trig again. Again, I've got adjacent, and now x is opposite. Well, I've got adjacent. I've got hypotenuse 10, sorry. And x is opposite, so I need to use sine. Sine of 36 is equal to opposite x over hypotenuse 10. Multiply both sides by 10. So 10 times sine of 36. Use your scientific calculators. 5.87, so let's round. That gives me that x is 5.9 inches. All right? X is 5.9 inches, so one of those side lengths, let's just say the sides, are all 5.9 times 2, 11.8 inches. How many sides are there in this pentagon? There's 5 of them, so perimeter of the pentagon is 5 times 11.8. Which is 59 inches here. So perimeter is 59 inches. We already found apothem. Now we've got perimeter. We can plug in area 1/2 apothem length. Recall that was A, that was 8.1 times perimeter, 59. Plug all of this in here. Area is 238.95, so the nearest tenth would round us up to 239.0 inches squared. All right. Next example, this is a composite figure. All right, so composite figures, if we want the area of this whole thing, okay, let's break it down into shapes. And these dashed lines have kind of already done that for you. You have an area of a triangle plus the area of a rectangle. I see a rectangle in there. Plus the area of that's a semicircle, so it's half a circle. And that's not a very good half circle, but we understand the idea here. So the area of this whole thing, you just add all of these areas together. So area is 1/2, for the triangle, 1/2 base times height. This is a 90-degree angle. All those angles there are 90 degrees. So that's a 90-degree angle. So the base of that would be 4 feet. However, we need to know the height. So we've actually got to use a little bit of problem solving on this one. So base times height plus area of the rectangle, which is just base times height. Parallelogram. Rectangle, same thing. And then area of a semicircle, that's half pi r squared. Pi r squared is an entire circle, so we take a semicircle, it's half of that. So what do we need for the triangle? We need the height. So we've got to use a Pythagorean theorem. We could use some other things, but I'll use Pythagorean theorem. 4 squared plus x squared equals 5.7 squared. That'll give us our x we've already labeled there. So 5.7 squared minus 16. 16.49, the square root of that, 4.1. X is 4.1. All right, and so the area of the triangle 1/2 base we said was going to be 4, height 4.1, plus the area of the rectangle, base times height, 4 times 7, length times width, however you want to think of that, plus 1/2 pi. The radius of the circle would be 4 squared. So just simplify all of this. This becomes 8.2 plus 28 plus 4 squared is 16, divided by 2 is 8. 8 pi. 8.2 plus 8 pi plus 28. The area of this shape is 61.3 feet squared. All right. So composite figures, just broke it down into shapes that you know the area for, and find those. All right. Thanks for watching the 11.4 video. Your homework 1 through 6, all